All right, so this is, I believe it's air handling unit 1. If you can't hear me, let me know or ask questions, whatever. Air handling unit 1, essentially air's moving right to left. There is outside air inlet all the way in that back four corner. I'm gonna open up the door, we'll take a look in, you'll be able to see it. Right to left, the return air section is up above it. It's perpendicular to the supply air. It's going from outside the building in this way. We're actually, sorry, inside the building out. We're relieving out the air out that side in right here. You can come take a look one at a time. You'll see the return air, outside air inlet right here, inside pre-filters, a wing coil for heating, and then on this side there's a lot of space in there. This side here you get the wing coil, and then there's the cross bracing for the structural steel. That was field fabricated. Yeah. Yeah.
That was the challenge in and of itself.
Yeah, oh yeah, they did actually an excellent job of it. Yep.
Because those were all covered with that fireproof material, or were they not?
Inside they still are.
Yeah.
They still are, yep. Okay. Here we have our electronic filtration. All the way down. So
Any concerns with this?
here's actually one of the electronic modules. Okay, air is going to go in through this side. It actually gets charged inside here by these, you can call them probes. So think about electricity, opposites attract. So in this field here, the particle is charged to be positive. And then on the downstream side, there's about a 6-inch piece of media, and you'll see there's metal clips on the bottom of them. It's charged negative, so it actually causes the filter media to attract the particles to it and do it. You can lose power. It doesn't mean you're going to dump all the particles. Without the power on, that's a MERV 8 filter. With the power on, it's the equivalent of a MERV 15. So what the purpose of this is, but you're only playing the pressure drop of a pre-filter, a MERV 8 filter. So the advantage of this is your HEPA filter should last longer. You're going to catch more stuff here. They're going to last longer.
What's the voltage on this?
The voltage is, I believe about 14,000 volts. It's 24 volts going in, and then we step it up. The amps, there's nothing there for amps. There's kill switches on the doors, you'll see, so you can't go in there. It'll kill the power to the filters. If the unit's controlled off, like right now the unit's off, so the filters are off. What else can I tell you about these? We have them over in AC 605 and 606 in the main building as well. They need to be replaced about once every 18 months.
What are you replacing, just the media or?
Just the media, yep.
Clean
Just like you would any other electrical piece of equipment. Wash out for dust type stuff, but no replacement. Keep moving down here. We've got the dry steam humidifiers, the XVs. I don't think you'll see them run today, but insulated distribution tubes. Yeah, the insulation just peeled off. Then we've got the inlet to the cooling coil side. A drain pan, it's all sealed off. Typical cooling coil. The fan wall. I'll double back and get questions on that end. Here we've got the outlet side of the fan wall, the fan array. Any kind of maintenance done on the motors, the fans will be done from this side. Sorry, that side actually as well, I forgot to point out the backdraft dampers. If you have a fan failed or a fan shut off, it will isolate it. And then our discharge plenum. And what we'll do is, if you want, we'll seal it up, we'll turn it back on, and I'll run you through the control screen a little bit so you feel comfortable with that. Does that sound good? We'll just shut all the doors.
What are those mesh screens there for? Just curious. I'm just never seen
Mist eliminators.
Oh, is that what it is?
Yeah,
Oh, okay.
they wanted to, just in case of potential carryover.
No, it's not. Cool.
Yep.
Thanks.
Yeah. On the inside, it actually has an antimicrobial, so that you can't get any mold growth on it. All right, so I put it into remote control here. The BMS is controlling it at this point. So it's giving it a start command. At this point, the discharge damper should be controlling open, which they are. They take about a minute. So once those dampers come on, the end switch will make, it'll allow the unit to come on. That alarm will clear once the damper's made. Pulse?
Yeah,
Getting pulse.
Like a lot of the units in the main building is 25% more, but these won't start.
Yeah.
So is it just set up the same way?
It's probably all the way open, to be honest with you. You'd have to ask him, yeah. Yeah, so should be coming on right now. There we go. So, inter CFM, that's the CFM you're giving it from your controls network, from the BMS. Total CFM, that's what I'm giving you back. Okay? Total static pressure, that's the difference between the high and the low side of the fan array. That's the total static pressure that the fan's doing. Speed of the VFDs, we'll get into this once it gets up and running. If I push VFD 1-8, I can see VFD 1 through 8, they're all on. If I wanted to shut one off, I could simply push disable VFD 1. It's going to take a second and it'll shut off. There you go. Now you'll actually be able to look up in that corner. The numbers of the fans, it's like reading a book. Start in the top left corner, 1 through 20, or 1 through 18 or whatever it is, 19 through 21. Sorry, there's 19 fans in this, so it'll be 9 and 9. So VFD 1 through 8, I'm going to turn that fan back. Did that damper isolate?
Yeah, it's still open. The motor's still running.
How can the motor still be running? Oh, it's in that back bottom right corner.
Oh, the bottom right?
Yeah, sorry.
What's that?
I mixed you up.
What is it, 19 fans?
There's 19 fans in there.
We got 10 on the top, 9 on the bottom.
I'll shut a different one off that we could probably see. I believe it's in 3 rows, right? Or 2? 18 fans, I'm sorry. So did fan 7 shut off?
Yeah, I see the
Did it- Yeah. So that's off. I'm going to turn one. I'm going to turn them both back on. Then you'll see 9 through 16 and 17 and 18 right there. If I go into system setup, so This is similar to the other units you have on campus that they'll give a signal, I believe it's 4 to 20 signal to this panel. From there, that's basically your 2/3 duct static pressure signal. From there, this program will calculate what's the optimal number of fans and at what speed to have on. So if I enable the optimization, it's actually, so when the system setup is set for 300 seconds, which is 5 minutes. So we're actually gonna have to wait before it'll actually start to do the optimization. We'll just keep going here. I'll come back to that. So I'll come back to that one. You can set the max hertz that these VFDs can do. Right now it's set to 60 hertz. That would have been set with the balancer. Time delay. So from the first time you turn the unit on, it will wait 20 minutes before it goes into optimization. And the reason why you want that one time to be long is because when you first turn a unit on, it depends on the speed of the loop. It could either take off really fast or take off really slow. And if it's hunting to figure out how many fans it wants to turn on and the unit hasn't settled out, you get into control issues with speed of P&ID loops versus ours. There is a P&ID loop inside our panel on its own, and they'll fight with each other. So if you wait that 20 minutes, you let it get up to speed, settle out, and then start dropping fans on and off, it provides a much smoother operation. I hit next screen. Adjust speed of control 25%. That's going to adjust the speed that our loop reacts to. So if the unit was hunting a lot, you could slow our loop down to not react as fast as, say, E&E's signal gives it, which would help it settle out. This has all been looked at during startup and it's been set for right now, but for a future thing, if something were to change, you could adjust it. Airflow adjustment, that's to adjust the K factor on the airflow stations. Here's the outputs for all the transducer. Each individual fan actually has an airflow station to it. Through the LawnWorks integration, you can actually get the individual performance of each fan. If one fan were to fail, you could get an alarm point of that exact fan. Maintenance screen. If you wanted to clean the screen, just push the clean screen button. It lets it go numb basically, so you can wipe it and you're not pushing a bunch of buttons. That's download, that's for factory upgrades. Calibrate the screen. You should have to do it once. I'll do it again here, but basically hit this crosshairs. And it's all centered to your finger. Password management, you can set up individuals' passwords. So you can each have a password, or you can keep it simple. Right now it's set up, it is user and 4 zeros. It's that simple. You will put in 4 zeros and then you'll hit OK and it'll come up and it'll look like there's 8 numbers. Just hit OK. There's only 4. It's only how many ever you put in. So it's leveled off right now. If I wanted to take it into local control, I push local control. The unit will shut down just like a VFD. If you go from hand off auto, you go into local or hand. Local control is basically hand control. And then you can go in, you can set your CFM. You would enter the CFM you want. Or some people are more comfortable controlling the hertz. You can disable CFM control, which would allow it to be hertz, and then control to the speed of the drives that you're most comfortable with, whichever way you're more comfortable. Any questions? Anything else? What's that, sorry?
Static set. What's typical static?
So this is the total static pressure. E&E, your set point is a different number. That would be through E&E. You'd have to talk to them. I don't know what it is. My guess is it's probably not that high by the looks of where we're at right now. No, we're low. Yeah. You're probably set at about 1 inch. That's the total of the fans. Your set point's just down in the ductwork. You know what I mean?
What's the system and remote?
System and remote. So that means right now E&E's controlling it. Your building management system is controlling this unit. If I want it, like on a VFD, you got hand off, auto, right? Hand means I'm controlling it. Auto means the BMS. So this is right now in auto. If I wanted to put it in hand, I would hit local control. And then I can, you know what, do you guys want to do it? Might as well. So if I want to control this thing in hand, I can hit local control. It's going to shut down. It's going to lose its signal.
It's basically just letting you know what mode it's in at that point.
Exactly. So I'm in hand right now. So it actually, you're going to see all these drives go to 15 hertz here because that's the minimum set point. So it's shutting down. Now, if I want to control to CFM, if I say, you know, if I know I need, let's pick a number, 20,000 CFM. I'm going to go to the enter CFM. I'm going to put in 20, hit enter, hit global start, and it's going to go and it's going to hold 20,000 CFM. Now, like I said, some people like to control to hertz. So I'll do that next. We'll let it get up, let it hold, settle out.
This is how you would control this if, let's say you had one motor that hadn't like completely failed but was on the way.
No, I would control it like this if I lost my BMS. I'll go through that scenario next.
In other words, you just wanted to do something, or maybe the fan kind of.
Yep, we'll do that next. Yep. Just remind me. I'm gonna do that. I'm gonna get through this and then we'll go that. All right. So now you can see it's locked in right around 20,000. It's gonna fluctuate a little bit, but I mean it's pretty low. So that's right around 20 hertz. Let's say I feel more comfortable controlling in hertz rather than CFM because you don't know what. You never really know what the CFM was, but you tend to always know what the hertz was. So I will disable CFM control, and now I can control by this. I'll put it up to 30 hertz. So I gave it an input of 30 hertz, and you can actually see each one's going to 30. You'll see my CFM climb. This inter CFM is going to stay how it was because it's not what you're inputting. You're inputting hertz. So it's got it locked at 30 hertz and it'll level off probably somewhere around 30,000 CFM is my guess.
And enable CFM control is going to take that last command of 20,000 and
go down. Yep. 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 So if I go enable CFM control,
it's going to drop it back down to 20 hertz.
Exactly. Or yeah, and if I put it to 30, yeah, exactly. Okay, so now I'm going to put it back into remote control, and we're going to go through the scenario that Forrest brought up. So let's say Forrest brought up a scenario. Let's say we had a motor that vibrating violently or was going to fail, or we had an issue with one of the motors and we wanted to run the rest of the unit but not that one motor. There's two ways to do it. The first, quick, if I'm the first kind of, we'll call it first responder, first guy on the scene, you hear it, I can simply go through into VFD 1 through 8. Now if I know which one it is, I just shut it off. Basically it's that simple. Boom, it's off. And if I don't know which one it is, you got to kind of, because I mean, if you had one fan vibrating, you can feel it or hear it. You can look in there. You're not necessarily going to know what it is, but I could say, okay, it's not 7. Sound didn't go away. Now I'm going to hit 8. Wait a second. Sometimes it takes a couple. There you go. There you go. Go through 8. Nope, not 8. Go through 9, and that is shutting off. And you can look in the backdraft dampers to verify it. They will be closed. Now, that's what I'd say is your first responder. That's just to diagnose it. From that point there, I'd recommend if you're leaving off for a long period of time, or more than an hour, you come in, you shut the panel down, you go inside, because each motor and VFD combination has its own individual disconnect. So you actually would open the disconnect so it could never come back on. Because Forrest could be walking through and he could diagnose it. Somebody else could come walking through and say, hey, that motor's off, I'll turn it back on. But if you've broken the disconnect, it can't come on. Any other scenarios you've seen or want to play through? I know we've been through that one.
Yeah.
On the individual one, they are not lockout, tagout. You can pull the fuse from it. It's a fuse disconnect. You pull it and take the fuse. But on an individual motor basis, no. Up here, yes. You can lock out, tag out the main disconnect. What's that?
That's the whole unit.
That's the whole unit's disconnect. Yes, you can lock out, tag out that. Anything else?
This one have an onboard UPS like you installed over in the engine?
Yes, it does.
Where's that low voltage compartment?
Right down here. You want to open it up? We can look at it. Let's.
It's not have it that way, it's 7 this way.
Who's got a screwdriver? I know one of you has one. Nobody's got a screwdriver?
Not during training, no.
Let's get a tweaker.
So this is your low voltage controls. Each fan has its own Cetra. You'll see. Each one has its own transducer. Fuses for each transducer. That's your PLC control. There's your UPS gun. E&E's relay, and then our internal relays. So essentially, if that relay is lit up, you know you're getting a run command from E&E.
That's the safety relay. That relay.
Oh, is that the safety? Okay.
Only that relay will be lit when all the safety circuits are good. You trip off on a smoke, low limit, high limit, low static, high static. That will drop out. If that's not lit, your unit will not run. And that's coming from us. When I do my side of it, I'll explain that. But that's what that relay is. And it's marked here. It says FAS safety relay. Is that relay out?
So funny. You have something so back there? Yeah. I want you to speak up for your own here. What?
Any more questions?
Most people walking by and you see the hertz on one of them was erratic with it. You shut it off right from the little control there, right there?
You would isolate it, whichever one it was, you'd isolate it here. You wouldn't. It can't.
You don't want to hit the.
But you can't. You'll get. They're all the same. It has to be, unless there's something catastrophically wrong. I shouldn't say never, because in the world of electronics, anything could happen. Now you'll see if there's a change, if you watch, it goes through, like, I mean, you're talking small changes, not erratic, you know what I mean? You will see a slight difference, and that has to do with the speed of the P&ID loop.
Where the high and low resets static switches?
That I think when E&E goes through their side for the controls, they'll show you. I don't know.
I think, Mark, you're on the other side. You're on the back side? Static safeties?
Yeah.
There's a return low up top. You have to climb the ladder and go up top. There's a return high on the other side. And I think you got 2 on the other side for the supply side.
You get 8 free stats, 1 outside and the rest inside here?
All of them are
Inside.
Yeah.
It has to be to the
And the one right here.
Huh?
The one
They might.
outside and the rest in. So you really never have to touch these things at all.
If you had a catastrophic failure of this touch screen and your BMS, you could get down to a level to control the drives individually. And then if you ever got to that level, it would probably, you'd be able to be at a point where you'd have an EPA technician on site. And now if you wanted to, and I could walk you through it over the phone, if you wanted to do it, you would set all the VFDs to the same hertz, not some at one, you know, not randomly pick them, because you want a harmonic balance, not an imbalance. And then you'd set them all to the same hertz, and then you'd hit run, 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 run. And I can go through that with you right now, just at least give you a crash course. If I hit this low re button, that's local and remote. With it not being lit up, it's in remote. If I push it, it would be in local. Then I would set the hertz, and I'd give it a run command.
The little LED on the corner here would light up.
Yeah, you know what? Let's do it. Let's do it. Let's do it. I'll just shut it off. So we're going to go through actually a scenario. The levels of redundancy are very deep into this, in that if this screen were to ever die, you could still control the unit through the BMS. In a situation where you lost this screen and the BMS, you could actually still get it up and running, and that I would control each of these drives individually. And to do that, I'd simply push this local, this is dead, let's ignore this screen. I'd simply push this local and remote button. Set my hertz. Let's set it to 20. Right, and I would do that, and I'd go through and do that to all of them. And then once they were all set, and they'd all have to be at the same hertz, because you don't want an imbalance. You don't want some doing 20, some doing 60. You set them all to the same hertz, and then I'd simply go through and hit run, run. And you'll see those two fans come on. You can see it's registering a flow right now. So I'm running two fans right now at 20 hertz in hand from the drive level. And the only scenario where you'd end up stuck with that is if you lost some kind of control interface within our cabinet, control interface with E&E, and your screen was dead. It would have to be pretty deep, but you could, there's always, I shouldn't say it, there's many different ways to get this thing to come on. You gotta be careful when you say that. You do need power though.
I'm showing this one here.
What's that?
This one here went to 0 here.
Because I never hit. I never hit. All right, the catch with that one, I know why. The catch with that is because the dampers, as soon as someone said alarm, the dampers were closed, so it was just pumping it up. That's why. So you'd have to manually get your dampers open, then you could do it. All right, so we're going through, I'll set them all, once they'll all be to 15 hertz, and then we'll put it in remote again.
All the flow to the 60 hertz.
I was looking for full flow, and it was in a run state, that's why. All right, so now it's coming on. So we gotta wait till those dampers open, then it's gonna all ramp up. Any other questions? Anything else?
So, let's say you do change 2. Is it going to basically do the same thing? Is it going to kind of override some of the other fans due to its volume, what it really needs?
No. If you're down to that, if you're down to this minute level, you're
just going to run those 2 fans?
You're running those 2 fans like they were individual.
You might have to manually open the dampers.
if you didn't have anything, you would probably, like I said, there's a way we can get it on, but as long as you have power.
Those don't operate together.
Not at that level, no. I mean, that's your worst. That's your last. I mean, you've had a lot of things go wrong to get down to that level. To run it in hand like this, yes, which is pretty typical. I mean, if you're down to this level, you've had a failure on your BMS, you've had a failure on this touch screen, and on top of that, probably a failure with our controls logic inside it. That's deep. Any more questions, scenarios you want to run through?
How many of these in the building?
These units, three units like this, HU 1, 2, and 3, and then 2 H&V units which just run off a single drive up on the roof.
3 units off the same size, 18 fans.
No, they're HU2 is 100,000 CFM. I believe this is 60. H60, it'll do 75 in emergency. HU2 is 80, but it'll do 100,000 CFM in emergency. And there you go. 60, 75, and HU3 17 and a half.
Is that Matt Hovind?
I don't know. Just had it handed to me. Whose is it?
Matt Hovind wrote that up.
Oh. Oh, okay. Yeah, you just handed it to me. Can I get your screwdriver again? I'll lock this back up. I'm just going to go through the components on this one. Outside air intake in the end. Return air comes through the bottom. Similar to the unit that we looked at down on 4, except for return airflow and supply airflow are in opposite directions, where before they were perpendicular with each other. So your return air coming in, outside air. We have a pre-filter. Then we have the HEPA filters, or sorry, the Stryon air filters, which we've seen before. A wing heating coil, humidifiers, cooling coil, and I believe this is a low temperature unit fed from the filtering unit. 4 fan array, fan wall with the backdraft dampers, the same controls as the unit down below, HEPA filters and a discharge out the end. Return air is coming back in the end up top. Got a set of pre-filters. Then we've got the return fan and then discharging out. There is actually an inlet sound attenuator on that one as well. No, it's relieving, sorry, good point. It's relieving out the end, and then the return dumps down and blends back in. Yep, sorry, good point. Yeah, absolutely. Because we're kind of cramped for space on AHU2, AHU2 is an exact replication of this unit, but larger. In fact, it's the same, just take this unit, put it over there. Airflow is still the same direction, same components with the filters, the wing coils, it's just larger.